The derivative of
yes.
P, derivative
yes.
of P of X.
Excellent.
Exactly,
So,
yep.
very good. So this is negative 2x plus 280, and yes, not in the same row, please, because every equation, or in this case, it's not an equation yet, I have to write negative 2x plus 280 equals 0. I move to 80, becomes negative, and I divide by negative 2. How much do I get? How many units? But again, finding the number of units does not guarantee max or min. I have to show that that is indeed going to give a max or a min. So, how much is x?
140.
Very good. So this is 140 units. But I don't know what it gives. But this is simple, very simple. It's a linear function, the derivative. So we do not study the sign of the function, only the sign of the derivative, first and second derivative. So here's x. I can manufacture from 0, not really to infinity, but you know what I mean. So this is 140. It's 0 for p prime. And if I want to find, we'll see if they're asking us to determine the profit, the maximum profit. We'll see in a moment. Okay, so I have to study the sign of the derivative. So please plug in 0 and tell me the sign here. And then plug in 200 in the derivative and tell me the sign here. When we plug in 0, what is the sign?
Positive.
Very good. And when we plug in 200, what will be the sign?
Negative.
That's it. Because it's this, increasing and decreasing, this is definitely a relative max. And now let's determine it. But now in the function, not in the derivative. I know the derivative is 0. So this is a critical number. 140 is a critical number. So now I have to plug in the function. Where is my function? Right here. So again, you don't have to do this. It's just a habit. Negative x squared. And then positive 280x. And then minus 5,000. And then we plug in 140. We know that this will be a maximum. So the maximum is 14,600. 14,600. Okay, what is the maximum profit? So this is part D. So we've answered part C, and this is exactly part D. P of 140 equals 14,600. This is indeed the maximum profit. And you can always tell our boss, if you want, if you want to produce 160, you're going to miss the maximum profit. If you want to produce 100, you're going to miss the maximum profit. The maximum profit is only obtained when you manufacture and sell, not if you put them on the shelf. 140, exactly, not less, not more. Okay, part D. What price per oven will maximize profit? Okay, so remember, this is the formula for the price. We obtained that X has to be 140. So this is the price per unit. I have to replace X by 140 to determine the actual price that is connected to 140 and connected to the maximum profit. So P of 140, lowercase p, or just say X equals 140, not to be confused with this. And from here we have 280 minus 0.4 times 140. And this will be the price. So what is this? If you have the number already, 280 minus 0.4 times 140.
224.
224. Thank you very much. So 224, remember, is the price per unit. that we should sell to get a maximum profit. Any questions? Any questions? Any questions? Okay, let's illustrate what we're trying to do here with another problem. 62 on page 331 caught my eye. Concentration. A drug is administered, I don't know if you can see here, you probably can't. A drug is administered into the bloodstream of a patient. The concentration of the drug, C of T, in the bloodstream in nanograms per milliliter, T minutes after being administered is given by. So I have C of T equals 110 E. I think there is a T in there. Yep, there is a T. So T E to negative 0.006 T. So 110 times T times E to negative 0.006 T. So this is in nanograms per milliliter, okay? And T is time in minutes. Always write the measurement units because remember, that's super important. What is the peak, which is maximum? What is the peak concentration of the drug in the bloodstream, and when does this peak occur? So we're asked to determine the peak of this function. So how would I think about it? What is my first thought, my first step? Anything you can say about it.
Find a derivative.
Very good. Awesome. Careful, because this is function 1 and this is function 2. So, indeed, C prime of T is first. Leave 110 alone. It can wait patiently. The first function prime is 1. E to negative 0.006 T. Plus, don't forget, whenever you apply the product rule, you have to have a sum of two different things. T stays, but now I have to differentiate this, which is e to a function. How do I differentiate e to a function? Anyone would like to help? Anyone?
It will be equal to the same function.
Negative 0.006 T times
The function prime, correct?
perfect. Excellent. Can anyone give us the function prime? Awesome.
Negative 0.006.
That's it. I'm going to write it one more time because it's not clear. So here it is. 110 e to negative 0.006 T. Exactly how I wrote it. You don't have to write it twice. But I just want to make sure it's clear. So you can skip this and just write this because I ran out of room. I always run out of room. That's never a surprise. The way I write with these markers and as big as I can. So next, what will you do next with this? What is your next thought?
Factor the inside.
Yes, I will factor what is common. That's the trick. Thank you so much. 110 e to negative 0.006 t. Let's see what is left. What is left from this term? Something has to be left from this term and something has to be left from this term. What is left from the first one?
1.
Exactly, thank you. And then, of course, this is minus. This is gone. So I have minus 0.006 times t. And that's it. So that's always super important to simplify by factoring. Good. So I found the derivative. I'm still looking for the maximum. We'll see if it's a maximum or not. We have to convince ourselves that this is true. What will be my next step now?
Set the derivative to 0.
Brilliant. So when I set the derivative equal to 0, this constant means nothing because it cannot be 0. This can never be 0. So these are useless. So the only thing that can be 0 is this. So 1 minus 0.006 t equals 0. So I either move this and becomes positive and I divide 1 by it, or doesn't matter. So it's still t equals 1 over 0.006. So let's see what that means. So 167. So t, or just keep it as 166.67 minutes. So the patient's concentration of medicine in the bloodstream after 166.67 minutes supposedly will reach a maximum. Do I know that for sure? No. I have to convince myself because who knows, I may have made an error. So t, time has to be somewhere from 0 to something. 166.67. Of course, we're not really talking about infinity, but you know what I mean. C prime of t, I know that this is 0, and I have to study the sign. And then I will find what this is. Okay, so here's the derivative. Oops, here. This is always positive, this is always positive. So let's plug in 0 here and just give me the sign.
Positive.
Very good, awesome. So let's plug in here 1,000 here. What will I get with 1,000? With 1,000, I move the decimal point 3 spots to the right. I will get negative 6 plus 1. What is the sign?
Negative.
That's it. So obviously this is indeed the relative max. It could be the absolute. I don't know. I don't care. It's definitely a maximum. This is the only critical number, and the function looks like this, so it has to be. But now we're asked to determine this. So in the function, I plug in 166.67. Okay, so here's my function. This is what I have to plug in. So I go to y equals, clear whatever, and I have 110. I have x, I have e, and in parentheses, you know I love my parentheses, negative 0.006x, close. Did I enter it correctly? No, I didn't. I said 110 and I wrote 100. Did I enter it correctly? Yes, 110x e2, that's correct. So now I want to plug in 166.67 minutes. Okay. So the concentration is 6,744.46 nanograms per milliliter. Okay, so I have to write that down. The measurement unit. So let me copy that. 6,744.46. And this will be in nanograms per milliliter. And this is the time. And this is definitely maximum. I showed, by studying the sign only of the first derivative and then the second if I need it, but no, I don't need it. I need it when I graph. Otherwise, don't waste your time with finding the second derivative, because if you determine this first derivative incorrectly, then everything else is wrong. So it's clearly that the sign change is correct for a maximum. Good. Any questions?